All right, good afternoon, everybody. I'm Erez, and with me, Jacob. And we will give a quick talk about ironing the cloud. Actually, this will be a preview for a talk that we'll have tomorrow, 9 a.m. Tomorrow will be the full talk, and you're all welcome. What we'll do is just highlight a little bit about what we're going to talk about and what's the motivation. So this talk is more around high performance and cloud and how they get together. For the HPC market, the high performance computing market, that's a very old type of market that's been there for some times now. And it is typically a homogeneous, very large clouds or very large deployments that typically are very homogeneous, at least in islands. And it is using typically the latest and greatest hardware in the market, you know, InfiniBand and GPUs and FPGAs, all those things just to get the performance. The performance in this world is the king. People are fighting to shave nanoseconds of latencies because in those huge scales of high-performance computing, when we're running deep simulations or very complex workloads that are very, very distributed, performance is, you know, shaving microseconds or nanoseconds can really change the total runtime of the system. So there's no compromises. In HPC workloads, performance is absolutely the king. The researchers that typically run on those systems are usually submitting jobs as batch. They have a batch system. They don't control the infrastructure. They don't control the granularity of the work. They just send the workloads that they need to do, and it is happening somewhere. This is the legacy HPC environment. Modern data centers, however, are very, very different, right? We're all in the software-defined area. The world is moving into cloud, so we want to manage everything in software, compute, storage, network, the infrastructure itself. It is all self-service. We want to provide our users the ability to provision themselves rather than provide them the solution. It is all about elasticity and scalability, with virtualization and containers as part of the whole solution. Multi-tenancy is obviously something that allows us to get more out of the system. And if you look at the whole solution, it's very much service-oriented. So you'll have the infrastructure as a service or the platform as a service and software as a service, and lately functions as a service, so all this serviceless environment. This is the data center of the future. HPC would like to use the same capabilities, the flexibility, the elasticity, the multi-tenancy, but there's challenges, right? So the transition is happening because HPC workloads are changing, are moving from standard simulations and other environments into things like machine learning and big data and AI, and they need the same capabilities. They need multi-tenancy to get more researchers and more organization into the system. They need the flexibility. If you look at this is on the right-hand side, this is the agenda of the last HPC Advisory Council, just happened last, or this month in Lugano. And more than half of the topics in this conference, which is a very hardcore HPC conference, was about machine learning and about containers and about virtualization and how do we get all the goodies in the modern data centers to be used in HPC. So the challenge is, how do we cloudify? How do we cloudify HPC? And the trade-offs are very, very simple. Programmability versus performance. This is what we have today, and what we're trying to do is we're trying to break this tie. We want to have both programmability and performance. So performance, first, when you move to virtualization, obviously you have a performance impact. You have a toll, both for the computation, but also for the networking, which both of them, by the way, can be addressed in a significant way. Another thing that you'll have is the ability to provision new hardware. So today there is GPUs, tomorrow there are FPGAs, and those orchestrated environments needs to be able to provision them. And the question is, how do you do that? And with this, I'll move it to Jacob.
Thank you, Iris, for a great overview of the opportunities and the challenges of HPC cloudification. I would like to add to this by providing a customer's point of view on this. I represent the CSIRO, which is Australia's national science agency. We're a big user of compute and storage. We've got about 2 petaflops and 50 petabytes on premise. And traditionally, we used to run classic HPC batch queue systems, which our users used to be pretty happy with, and they still are. However, in the last few years, we've seen an increase in demand for either dedicated HPC systems, which have very different configuration than the shared system we mainly run. We also have users that need more flexibility, so they're looking forward to a more cloud-like experience. We're also heavily investing in cybersecurity research, and that field obviously brings its own set of challenges, especially around the network isolation and SDN in general. And last but not least, as we look at our utilization patterns throughout the year, we see a significant amount of fluctuation. So we're thinking, if we can take a cloud-like approach where we convert systems into applications, ideally cloud applications, we can probably address some of this in a very efficient manner. So if we look at what we've got today, is we've got the classic HPC systems that we all know and love, and our users are absolutely addicted to the performance that they provide, and they'll never give it away, let's face it. If we can't build something that provides the same performance, they're not going to use it, at least not most of them. On the other hand, we've got cloud systems, either on-premise or public, that do provide superior flexibility that Erez touched on. However, till now, it hasn't been possible to deploy those without observing any of the overheads, let it be on the CPU, memory bandwidth, interconnect, or local I/O. And there are many tools that we can use to address those, but it's very difficult to make it go 100%, and for HPC users, that's a showstopper. However, there are new solutions coming up that can address that, and if we can implement a solution that combines the raw performance of classic HPC with flexibility of cloud, that would be a great asset to the CSIRO. That would really help us improve things and do better. So basically, the question is, how do we have the cake and eat it too? I'll tell you about this cake tomorrow. So we believe that going with Ironic-based OpenStack and supplementing it with software-defined InfiniBand can do exactly what we want. Why? Because using Ironic gives us the raw bare metal performance that our users expect, and the SDN gives us the flexibility to make things multi-tenant and secure. So all in all, we'd end up in a situation where we can have the performance, and we can have the flexibility. And that is very, very powerful. We can basically start applying DevOps and infrastructure as code methodology to scientific applications. And we can use this as a foundation to build next-generation scientific applications. And we can take full advantage of our storage systems that we're building up as well. So we're aiming to achieve hundreds of gigabytes cluster to cluster and 10 gigabytes a second a client. And in order to be able to do so, pretty much forced to go bare metal and InfiniBand. Just to give you an idea what we expect in terms of performance increase, I think that's a pretty accurate way to compare a KVM-based system with 10 gigabit Ethernet links that carry NFS TCP traffic. Then on the other side, you've got bare metal, so no KVM overheads, and native performance of InfiniBand. So we literally think that this is going to fly compared to what we used to do in the past. This pretty much concludes our presentation. I also wanted to mention that we will have a deep dive session tomorrow, as Erez mentioned. Our colleague Moshe Levi will join us. He's the principal developer who's architected the SDN solution that we're relying on this project. And also, we have a demo that will illustrate the end-to-end workflow of provisioning Ironic instances with software-defined InfiniBand interconnect. This concludes our presentation. Thank you very much.
Thank you.